Welcome to section 3.5. Today we're going to continue our lecture on graphing linear equations. Specifically, we're looking at the slope-intercept form of equations. So remember, slope-intercept form is of the format where y equals mx plus b, and it helps us to identify both the slope and the value of the y-intercept. And both of those can really help us with graphing fairly quickly. So, first question that we have is negative 7x plus y is equal to 3. And the instructions say graph using the slope-intercept form. Right now, we're not in slope-intercept form, but we can solve for y pretty easily. So we have y is equal to 7x plus 3. We can identify very quickly that our slope is 7, and our y-intercept is 0, 3. So we have those values already set for us. We need one additional point to graph. And so what I'm going to suggest is let's just get a little XY chart. There are different methods and kind of like a cheating method, if you will, if you're just trying to count the points. But an XY chart will work every single time that you're graphing. So I highly suggest just getting into the repetitive form of using it. So we already have 1 point, 0, 3. Let's just get one more point. Let's put in a 1. So I have y is equal to 7 times 1 plus 3, which comes out to 10. So 110 is my next point. Okay, so at this point, let's go ahead and graph. So I have 0, 3 right there. And I have 110 right there. And there are my points graphed. We're going to pretend that I can draw a straight line. There we go. Excuse me. And so there is our graph. That's what we have. Pretty straightforward, very simple. It should be some pretty embedded practice at this point for you, as you've been graphing for a couple units now. Okay, let's try the next one. The next one is y equals negative 4x. Is this already in slope-intercept form? Yes. So we can identify the slope is negative 4. The y-intercept, there we go, is through the origin of 0, 0. Remember, if you don't quite see it, technically this is a negative 4x plus 0. So if you need to write that value in, you absolutely can, but I did not because I did not need to see it. Okay, so if we were to graph, we again already have 1 point. We need one more. So we have 1 point at the origin. Let's just plug in 1. If I plug in 1 to my original equation, I'm going to erase that. If I plug in 1 to my original equation, I know y is negative 4. So I have a point at 0, 0, and 1, negative 4 right there. And that line is actually far straighter. Okay, so graphing-wise, pretty straightforward, very easy, I think. It really comes down to just repetitive motion going through these problems. Again, when I say graph, you say XY chart, go math. That's because the XY chart works every single time you're graphing. That being said, let's shift gears just a little bit. And the reason I want to shift gears is because I really want to expand your understanding of slope through this discussion. So the last time we spoke, we had our slope formula. Let's get that up here so it's nice and clean. Our slope formula, which was the change in y over the change in x. Ooh, there we go. Now, given our slope formula, we can actually get an equation here pretty easily. And that's if we understand the slope and at least 1 point. So let's assume that we are given a slope and a point of, let's say, x1, y1. it might help if I actually close that off. There we go. Let's just say that, which means technically for our purpose, x2 and y2 would be an unknown. So we're kind of changing that point around just a little bit. Now, that being said, we didn't shift anything in our problem yet. We haven't changed anything. We're just getting to the understanding that we would have a problem with a slope that's already given to us and a single point that is then also given to us. With this understanding, if we were to multiply and simplify this as much as we could multiply to clear our denominator, and thus you would have mx minus x1 is equal to y minus y1. And this is what we call point slope form. And you may see it written as it is also on your paper where the y's are on this side, the m and x's are on this side. It's the same exact thing either way. But point slope form is extremely useful because if you're trying to create an equation and you're given only a point and a slope, or you can identify a point and a slope in the graph, you can write the equation from here. It's pretty straightforward. It's actually very easy. So let's say we have the point that's given to us of 0, 5, and a slope of 4. From the point of 0, 5 and a slope of 4. All we have to do is plug in what we know and then reduce it. So we have a slope of 4. I'm going to rewrite this just so that we are consistent throughout the lecture notes, just so we're very, very consistent. This is the same exact thing. I just flipped around my y's and my mx terms. Okay, that being said, I have y minus 5 for my y value is equal to m, which is 4, times x minus 0. Okay. Go ahead and distribute here. Four times 0 is 0, so I didn't bother writing it. Add your 5 over. And you have your equation for the line that passes through 0, 5 with a slope of 4. Now, you may be thinking, okay, why? Why are we doing this? Well, let's say you're looking for any solution on that line. If you only had this information and you tried to look at it graphically, you could be looking at that graph for a very, very long time before you actually came up to the solution you're looking for. This is very common in business practices, for example, looking at things like supply and demand and where those values would actually intersect. This is allowing you to get the actual equation fairly quickly. And getting this equation then opens that door so that you can do further analysis. So let's do another. And I'm going to erase all of this information. You do have it on your paper, but I am going to write my equations off to the side just so we have a running list of equations, because we've talked about a few different ones thus far, and it's very important that we keep track of what we've seen. And of course, you had standard form as well. There you go. So we've had 4 different equations. We've had slope intercept, we've had point slope, which we just practiced, and we've had standard form. So keep in mind all 4 of these equations. It might be good to have that off as a side note as well. But we're going to do another problem, and we're going to work through point slope form for this problem. So we're going to pass through the point of negative 2, 4, and we have a slope of negative 3/4. Okay, so at this point, what we're going to do is we are going to take our point slope form and plug in. So I have y minus 4 is equal to a negative 3/4 times x minus a negative 2. It's okay to use parentheses, especially around those negatives, so that way you don't lose the sign. At this point, we need to start distributing. Keep in mind, you have a double negative here, so if it helps, write that intermediate step where those double negatives would become a positive before you do your distribution. All right, very good. I'm just going to bring this down to this step because nothing has changed. Okay, over here, we're going to go ahead and distribute. That's negative 3/4 x minus, sign change, be very, very cognizant of that, minus, this will be 3 halves. Now you may be saying, wait a minute, where'd you get 3 halves from? Whenever you're multiplying your fractions, remember you're multiplying to the numerator, and then you can simplify. If possible, do so. So in this case, 2 times 3 is 6. 6 and 4 can both be reduced, and so I got 3/2. Okay, very good. At this point, I need to move that 4 over to get into slope-intercept form. So I have y is equal to negative 3/4 x minus 3 halves plus 4. Now, I'm going to do something a little different with my 4 because I have a fraction over here, but this is a whole number. So I have to multiply this 4 by 2/2. I'm going to do that right here. It's technically 4/1. It's a whole number still. I have to multiply this by 2/2 to be able to get that as a fraction that would then have a common denominator between my fractions. Just taking that a step further, just so we can see how this rolls out. You'd have 8/2, which is what you're officially adding over. Combine these like terms. And you get y is equal to negative 3/4 x plus 5 halves. And that would be your equation. Okay. Very good. Let's do another one. All right, next point that is given to us is negative 4/12, and it says our line is horizontal. What is the slope of a horizontal line? Remember, that's a line like this. So what we're looking at here is technically they're giving us the slope. They're just not saying it. So the slope is 0 because we have a line with no change, which is horizontal. Now, we can still use point slope form here. So let's go ahead and do that. I have y minus 12 is equal to 0 times x minus a negative 4. I'm not going to worry about this side too much. Here's why. 0 times this is 0. So I have y minus 12 equals 0, or y is 12. Pretty straightforward. Very easy with horizontal lines. And you might have already identified that. You might have said, well, this is a horizontal line, so I just got to look at my y value. Fair enough. You easily could. I challenge you to look at this one. Same point, negative 4/12. But what about a vertical line? What would be your equation here? Remember, vertical lines have undefined slope. So an undefined slope is not going to play nice through your equations. But you could easily say that this is x equals -4 because you're only looking at the x value. It's a vertical line. All right, let's step up the challenge, shall we? Let's step it up in the sense that I'm not going to give you a slope. I mean like that. Let's say that you have 2 points. How in the world do you get an equation from 2 points? We almost need something that can process 2 points to give us something useful. Something like, oh, I don't know, how those points are changing, like a slope. So let's use that slope formula. We have 2 points. We have a slope formula. We have the technology. All right, so I have 5 minus 1 over -2 minus a -8. Remember, it's very important to keep your points together as you're going through this process. 5 minus 1 is 4. Beautiful. -2 minus a -8. That's like a -2 plus 8, which is 6. This can reduce, so you should do it. You get a slope of 2/3. Beautiful. Now what? You're not done because you haven't found your equation yet. All you've done is you found a slope. Beautiful. What you need to do is now jump into point slope form. Oh, but I have 2 points. Which point do I use? Does it matter? No, because both points are on the line. So pick a point. It does not matter. I always suggest picking the point that is easier out of the two. And if you're not quite sure which one that is, or if it's not very clear if one's easier than the other, then it really doesn't matter. Just pick a point and go for it. Go for it. So I'm going to pick just the first point. Why not? So I have y minus 5 is equal to a 2/3. There we are. Times my x minus a -2. Works for me. Y minus 5, do my distribution. Watch your signs here. Watch them, watch them, watch them. That's 2/3 x plus 4/3. I got to add my 5 over. Remember, when you're adding that 5 over, because it is a whole number, you have to get a common denominator. So I'm going to add 5, but it's going to actually be 15/3. My common denominator here is 3. So what I'm doing is multiplying by 3 over 3 to get 15/3. Simplify this. I have y is equal to 2/3 x plus 19/3. And there is your equation. Okay, let's try another one. We're going to step up that challenge just a little more, really force you to go through it. So I have 7/2, and I'm told that I am perpendicular. I'm using the abbreviation. I'm using the symbol here. Perpendicular to -x plus 3y equals 12. So I have the point of 7/2, and my line will be perpendicular to my given line. Oh boy, what do I do? Well, I still need to understand the rate of change. I still need the slope. So what I have to do at this point is solve this problem for its slope and then determine my slope for the actual equation I'm working with. So let's figure out the slope here. So first things first, I need to move that x. So that's 3y is equal to x plus 12. Divide by 3, y is equal to, y is equal to 1/3 x plus 4. All right, so what is the slope of this line? 1/3. Now, what does that mean for me? What is the perpendicular slope to 1/3? Remember, you must meet both conditions here, opposite and reciprocal. It's an OR slope, opposite and reciprocal. So opposite would be negative here. Reciprocal would be 3. So this is this given slope that you're working with. Go back to point slope form, if I can speak correctly here. Yeah, y minus 2 is equal to a negative 3 times x minus 7. Go ahead and do this. You have y minus 2 is equal to a negative 3x plus 21. Y is equal to a negative 3x plus 23. And there is your equation. Okay, very good. Now, at this point, at the very bottom question on section 3.5 is asking you to write the equations for parts A, B, and E, which we've already covered, in standard form. I'm not worrying about standard form, so don't feel like you have to complete that part. If you are planning to write in standard form, just note that A, B, and C here are constant values. They are whole number values and integer values, so you're not going to have fractions or decimals through these 3 different values. But that concludes our lecture for 3.5. I plan to go into 3.6 here in just a few moments.